This question is an easy question on LeetCode, maximum subarray. Question reads, given an integer array nums, find the contiguous subarray containing at least one number which has the largest sum and return its sum. And the sample input is this, and as you can see, the maximum sum is 6, which is starts from this index all the way to the 1 here. And that is the maximum contiguous subarray that sums up to 6. So how do we solve this problem? Well, this problem looks like line window problem. What we have to do is that so the naive approach is you take the first index here and then you use a different loop to sum the rest of the elements to see the one that has the largest. You then change the index to this one, and then again you sum the other elements to see how they compare to the big O of n square. But we want to tackle this using big O of n. So how do we go about it? I think we can initialize this item with the maximum. For the beginning, we initialize this as the maximum, and again initialize this as the maximum so far, because if you realize, there's no need for us to, if we are checking the sum of this and compare it to the sum of just this, that is a waste of time, because this is 1 and this is -2. This alone is bigger than this. So if we had already checked this, then we are also checking the combination of this and comparing it to just this. That will waste time. Imagine going through all. Since we are looking for contiguous subarray, if we check this and then we compare it to this, if this is bigger than this, then we do away with the negative here. We do away with this one, right? Same way, then we shift the window to this one. We compare it to -1. Is -1 better than our current best? No. So we leave it like that. So we have a contiguous array of 1 and -3. Then we proceed to 4. 1 plus -3 is going to give us -2. Is 4 better than -2? Yes. So we ignore everything from here and take the max, which is this one, at our best so far. We check for -1 here. Is -1 better than 4, or is it in terms of max, is it better than 4? So we add it here to make it 3. Is 2 better than 3? No. So 3 still wins. So the index still stands here. Then we add this, giving us 5, right? Then we compare it to the next index element, 1. Is 1 better than 5? No. So we add 5 to that. We add 1 to the 5, giving us 6. Is -5 better than 6? No. So our max still stays at, we add this one. So here we are still storing the best that we get so far in any of them. So far this is our best, which give us 6. So if we add this -5 to the 6, we get 1. Is 4 better than 1? Yes. So our new we move our index to this 4, and then that will be the end of the array. But then we recorded here that this gave us our best so far, which was the 6. So that's what we print out. Okay, so let's see how we code this. So we find max sub array nouns. So what we need to do is that we can initialize, we can do something like the best so far, the best so far, um, the best so far, or max so far. Let me make a max so far. Max so far sounds better. So max so far, let's initialize that with the first item, and then our max at every end, max at end, right? So that one, to initialize it for now, let's initialize that with this one. So what we can do is that we can do for all the numbers, so for I in the range length of the array, what we can do is that we can then compute for the max. So our max at every particular end is going to be the max of this max, the max that we had at the end, plus, right? So plus the current index, current index, right? We're starting from 0 here. We need to start our index here with the one. Then we compare that to that particular index that we are on so far, and then max. So yeah, max so far is going to be the max of the max at that particular end, and the max so far itself. Okay, so then we return max so far. Right. So this is going to be big of n, and then the space complexity is going to be big of 1 constant time. Now let's run this and see how it goes. Okay. All right.